Well, good evening. I want to welcome everybody to this week's session of the Sagis Happy Hours. We are going to be discussing bugs, worms, and other things that go bump in the night. Be taking a look at some arthropods, some helminths, and some flukes. And for those of you who have a particular interest in this topic, I would refer you to an old AFIP fascicle. It's called Pathology of Tropical and Extraordinary Diseases. Let me see, I think I'll see if I can type it in the, in the chat here. Pathology of Tropical and Extraordinary Diseases. You can get it on Amazon and also I think on eBay. It's about $50 to $100 two-volume fascicle. It's just got some great pictures in it. It's a little bit older, but if you've got an interest in helminthic infections, etc., you'll be able to see incredible photos there and very good discussion. If you have any questions at all, please feel free to enter them in the chat if you're watching live. If you're watching the recorded version, you can always email us at education@sagisdx.com, or you can email me directly, tdavis@sagisdx.com. So with that being said, we'll go ahead and get started. Our first case was a little bit pedestrian here. And we have a bisected shade biopsy from pretty severely sun-damaged skin of the face. You can see rather pronounced solar elastosis. The epidermis is thin with some effacement of the reedy ridge pattern, which we tend to see in photoaging. And hopefully you all notice the dilated vessels present within the dermis, some telangiectasia. And there's a little bit of a perifollicular infiltrate of lymphocytes, also distributed in a somewhat perivascular fashion. And these changes are pretty characteristic of classic rosacea. A lot of times we'll get biopsies of rosacea that will come in as this one did. Is this rosacea or is this cutaneous lupus? And of course, there's no interface change here to suggest lupus. The reason I threw this slide in is because it nicely demonstrates the presence of Demodex mites within the hair follicle. And I know on some of the recent cores, the testers expected you to be able to recognize Demodex mites. Demodex mites, of course, there are two species that are found as normal inhabitants in human skin. The larger of the two is Demodex folliculorum. It's about roughly 0.5 millimeter in length and usually exists in colonies. So there's usually more than one mite in a follicle. And so this would be Demodex folliculorum. The second species that we'll sometimes see is smaller, Demodex brevis, and it lives in sebaceous glands as a solitary unit. So you'll see the Demodex mites not only in the hair follicle, but also in the sebaceous glands. Now, it's generally accepted, as I'm sure most of you know, that in the normal variants of rosacea, Demodex probably don't play that much of a role. However, they may play a role in granulomatous rosacea, and certainly in some of the crusted and really inflammatory forms of rosacea that we see in immunosuppressed patients. Demodex likely plays a role. Also, one variant of demodicosis that's been described, of course, is a localized pustular folliculitis of the face. And I remember the first time that I saw that, I thought the patient probably had tinea faciae. So I went ahead and did a KOH prep. And on that KOH prep, much to my surprise, rather than seeing hyphalenolence, I saw myriads of Demodex mites. And so we treated him appropriately for demodicosis with a prompt response. So anyway, I would recognize the the morphologic appearance of Demodex mites and be prepared to identify them on your Dermpath core. You can probably Google some wet mounts as well, KOH preps, and take a look and study the morphology of the Demodex mites. So again, the first case, the diagnosis was rosacea. Mainly just wanted to point out the morphology here of the Demodex mites. Okay, continuing our arthropod discussion. The second biopsy here, so if I can back out a little bit, a bisected punch biopsy. This is likely from the trunk or proximal extremity. You can see we've got a relatively thick dermis, certainly not a high concentration of follicular and sebaceous elements. And there's a very robust nodular infiltrate here. Nodular is a little bit perivascular and interstitial. And again, when you see an infiltrate with a prominent interstitial component, 9 times out of 10, it's going to be mixed. And so we'll want to go down and take a look at the nature of the infiltrate. And if we move into higher power, we can see that there are a lot of lymphocytes here, these cells with small round nuclei, little discernible cytoplasm. And there are smaller numbers of histiocytes present within the infiltrate as well. And hopefully you were able to pick up on the presence of numerous scattered eosinophils. And many of these eosinophils are located not just in a perivascular distribution, but interstitially between collagen bundles. And when we see these eos interstitially between collagen bundles, of course, we can think of a variety of hypersensitivity reactions, including responses to arthropod assaults and infestations. And the key to the diagnosis in this case, this was an example of a tick bite reaction, was the identification of the tick mouthpart, this chitinous structure present within the dermis, and surrounded by degenerated collagen and a fairly dense mixed cell infiltrate, lymphocytes, plasma cells, eosinophils, and histiocytes. Sometimes one can see cementum and altered collagen in the dermis too. That can be a clue to the diagnosis of a tick bite reaction, persistent tick bite reaction. So this is fairly characteristic of a tick mouth part. It's got some spines here along the surface. Occasionally one can see the tick body too on the surface of the specimen. So a persistent tick bite reaction. And of course, these ticks are blood-sucking arachnids. Let's go ahead and move on to case number 3. And case number 3, we have a trisected shade biopsy specimen. And I think quite striking, even on scanning magnification, is the fact that we've got a markedly thickened stratum corneum. Stratum corneum's thicker really than the epidermis, since there's a lot of scale crust there. The underlying epidermis is irregularly hyperplastic. And of course, if we look in the quantified layer, we see innumerable mites, there are ova, there is sabala or mite fecal material. And then we also see these chitinous scrolls and curlicues throughout the quantified layer. And these represent chitinous fragments that turn inward. They're fragmented mites and ova that are retained in the stratum corneum. Of course, the diagnosis in this case is crusted scabies. And the scabies mite has a very characteristic appearance. These are, of course, are gravid females. And if you look inside, you can see that there is skeletal muscle within the mite proper. And then we get these dorsal spines on the surface of the mite. So this is very, very characteristic of crusted scabies. We'll go ahead and move on to case 4. And in case 4, we have another organism here, another arthropod that likes to kind of hang out in the stratum corneum. Of course, you can see right away that this organism is much, much bigger than the scabies mite. And if we take a look at the biopsy specimen, you zoom in and pull it down a little bit, you can see that this biopsy is from a volar surface. We've got a very thick stratum corneum here. The epidermis is irregularly hyperplastic, and there's an absence of follicular units. And embedded within the stratum corneum here, what we have is a gravid sand flake. This is Tunga penetrans. This is an example of Tungiasis. Now, these sand flakes can't jump very high. And so most often we see the gravid female embedded in volar surface, usually the feet. These can be picked up from the sand. I have rarely seen them in the hand, and somebody who's been laying on the beach. I saw one case in the buttock where a nudist had laid in the sand for a long period of time. But the gravid female sand flake burrows into the stratum corneum. And this organism has a very distinct appearance. What we see is this thick chitinous wall, and we'll zoom in, and you can see that there are spines on the wall. And then when we look at the internal structure, we can see blood-filled gut. You can see all the red blood cells here in the gut. And then we've got a number of these kind of clear staining tubules as well. And in addition to that, there are internal fragments or aggregates of skeletal muscle. And this structure and the location within the stratum corneum will enable you to identify the Tunga penetrans causing Tungiasis. Now, there is another organism that is also quite large, another larval form of an arthropod here, and that would be our next case, case 5. This is a botfly larva, and this is an example of Myiasis. This is an excisional biopsy specimen from the scalp, and one can see in the deep dermis and largely in the subcutaneous tissue, we have a very large botfly larva. And like the organism causing Tungiasis, this tends to have a rather thick chitinous wall. It tends to be much more corrugated than that of the organism causing Tungiasis, the Tunga penetrans. And it's characterized by these ochre or golden brown setae that anchor this botfly larva into the skin. Usually there is an associated brisk inflammatory infiltrate present within the surrounding dermis. But again, the location of this organism deeper into the dermis and these ochre-colored setae are critically important and can lead you to the correct diagnosis. This organism communicates, or the larval form communicates to the surface. There's a little breathing tube right here, and actually if you close off that tube, you can suffocate the worm. Trying to extract these causes quite a bit of pain for the patient because the setae anchor it to the skin. But a lot of times if you inject with lidocaine, it can paralyze the larval form, making it easier to extract. The botfly has a very interesting life cycle, as I'm sure most of you are aware. The female botfly actually grabs a mosquito and lays the eggs on the mosquito. The fly doesn't bite the host, the human. A mosquito does, and when the mosquito bites the human, the eggs drop off, and the warmth of the skin causes the eggs to hatch, and then the larval forms will migrate down into the skin. This particular case came in as a follicular cyst. Neither the patient nor the doctor were aware that there was a botfly larva present within the underlying subcutaneous tissue. The woman picked it up on a cruise in the Caribbean. She was off the coast of Belize, never really got off the boat, but they must have been close enough to the shore that there was a botfly or a mosquito that better deposited the botfly larva. So myiasis differs from tungiasis in the fact that it's deeper and again has these characteristic ochre-colored setae. Okay, time to move on to some worms here. And we'll take a look at cases 6 and 7. And they're examples of conditions which are caused by a nematode or roundworm. In this case, it's Onchocerca volvulus. And Onchocerca is transmitted by black flies, Simulian black flies, and they tend to breed near rivers. And so the disease worldwide tends to cause a lot of disease and tends to affect communities near the water, typically in Africa and also in Central and South America. And the first slide that we'll look at, case 6, was an example of an onchocercoma. And we can see that within a very fibrotic subcutaneous tissue, the dermis is also fibrotic here. Basically, we have a circumscribed nodule, and this is really a mating ball or sex ball. And there are both male and female worms in this onchocercoma. And the females are gravid. I don't think in this particular section you can see the ova, but when you do, you can see microfilaria there. And the microfilaria are deposited or released by the female, and they get into the lymphatics. And from the lymphatics, they can then get into the skin and the eye. But these nodules can occur anywhere on the body. When I've seen them, they've frequently been on the leg near the groin. And if you take these out and cut them, you can actually see the worms moving. It's kind of gross. But this is an onchocercoma, and again, caused by Onchocerca volvulus, which is a nematode roundworm. The slide number 7 was an example of onchocercarcal dermatitis. And this is caused when the microfilaria that we alluded to before get out of the lymphatics and into the skin. And in these sections, it's very, very subtle. We have a very sparse inflammatory infiltrate within the dermis. This is a large shade biopsy specimen from the trunk. And if we go down and take a look at the inflammatory infiltrate, we can see that we've got lymphocytes, a rare histiocyte, and if you looked around, there were a few scattered eosinophils within the infiltrate. And if you looked carefully in the dermis, you could see an occasional microfilaria. I'm getting my pencil out here, and this is one of these microfilaria right here. You can see they're linear, and they've kind of got a dark center and a little bit of a clear halo around that dark center. So this is one of the microfilaria organisms causing onchocercarcal dermatitis. Patients with onchocercarcal dermatitis tend to present with a pruritic papular eruption, and it tends to cause dyspigmentation of the skin. The organisms, obviously, as I'm sure you're aware, the microfilaria can also get into the eye and cause a keratitis and produce blindness, the condition known as river blindness. So 2 manifestations, 6 and 7 of infestation with Onchocerca volvulus, first an onchocercoma, second onchocercarcal dermatitis. Case number 8 was an example of Sparganosis, which is caused when the larval form of a tapeworm gets into the skin. And humans are usually an intermediary, secondary host. And typically, the patients will present with subcutaneous nodules. And then where you want to focus your attention here, we've got epidermis, dermis, we've got a lot of skeletal muscle here. And then within the deep portions of the subcutaneous tissue, See if I can get this to zoom in. We've got the cystic space. And within the cystic space, we have fragments of this larval form of a tapeworm. And these tapeworms don't have any gut. And what you see in the tapeworms are fragments, or not fragments, but fascicles of smooth muscle. Some are cut longitudinally, some are cut in cross section. And then you see these calcified structures. These are calcareous bodies, and they represent calcified waste material. Again, the organism has no gut. And so this is an example of a sparganosis. And our last slide, we're getting out into the weeds with these last three, with the onchocercarcal dermatitis, the sparganosis, and the schistosomiasis. I think those are pretty unlikely to be tested on your boards, whereas some of the earlier slides I think are fair game. But case number 9 was an example of schistosomiasis rather. And this was a fragmented portion of a nodule in the genitalia. The causative organism is a fluke, schistosoma, and this was an example of Schistosoma hematobium. And what one sees, I'm sorry, this is a very, very dark stain, but within the fibrotic dermis, there's a dense inflammatory infiltrate, and there are eggs deposited. These are schistosoma eggs within the dermis. And in a few areas, one could appreciate that some of these eggs had an apical spine, which is characteristic of Schistosoma hematobium, tends to affect the bladder. And the eggs are frequently deposited in the bladder wall, but they can get into the skin in the genital crural area. So schistosomiasis here. Again, this is, like I said, getting kind of out in the weeds. But so running through the deck real quickly here, I think for board purposes, I would definitely be able to identify Demodex and in H&D stain sections, possibly on a wet mount. I would know what tick mount parts look like. I would definitely be familiar with scabies, as well as Tungiasis and Myiasis. And I probably recognize what an Onchocercarcal look like, because they all tend to look very similar. So anyway, I hope the session was helpful. Again, if you want to do some more reading, I would strongly encourage you to look at that AFIP fascicle, the pathology of tropical and extraordinary diseases. Most path departments and institutions will have a copy of it, but again, you can get it for $50, and it's really an excellent resource. So if you have any questions, please feel free to reach me, and if not, you can email us at education@sagisdx.com or tdavis@sagisdx.com. Thanks so much. Have a good evening.